Swayam Prabha. Digital India. Educated India.
Today we are going to talk about some of the tactical and operational decisions which are relevant in production management. You will recall that till now our focus has been on strategic decisions like choice of a product, choice of a process, designing of the layout, fixing up the location of a plant. All these decisions are essentially strategic decisions which are generally taken only once in the lifetime of a particular production system. But for a system to operate, a large number of operational level decisions are required. Decisions regarding production planning, decisions regarding scheduling, decisions regarding materials planning, decisions regarding inventory. And in fact, all these decisions require that you have an estimate of the forecast of demand. So we are going to be talking in today's lecture about forecasting and various methods of forecasting. We must remember that forecasting, as far as we are concerned in production management, is essential for a number of planning decisions. Forecast is essentially used not merely for the purpose of making a forecast, but for finding out or taking more effective planning decisions. Now here are some examples of planning decisions in which forecasts play an important role. We can talk about long term decisions, and in long term decisions like new product introduction or a decision like expansion of a plant. These decisions require that you know what the demand for the product is going to be in the long run, so that you can decide upon the right kind of production capacities and which product to introduce when. These kinds of decisions. We then may talk about medium term decisions. By medium term decisions we mean those decisions which have a planning horizon of, let us say, 6 months to 1 year or 2 years from now. So the category of decisions which are more important in this category are aggregate production planning. Aggregate production planning decisions are basically decisions which tell how much you should be producing in each month to meet a fluctuating demand, because demands often keep fluctuating, whereas the production capacity is more or less constant. And of course you can have variations in production by varying the level that you operate on, and what should be the optimum level that you should operate upon for the next 1 year or so is basically an aggregate production planning decision. Then you have decisions pertaining to manpower planning. What should be the quantity of manpower that you should recruit, and how you should go about deploying this manpower are again very vital decisions in the context of medium term decisions. Determining the right inventory policy. How much should you stock, how much you should order, and what should be the maximum permitted level of inventory. These kinds of decisions are again decisions governed to a very large extent upon the extent of the demand forecast for individual items. Then apart from this, we have short term decisions in the context of a manufacturing plant, where we are talking about decisions like production planning. how much to produce. So, there are 20 jobs to be done today in a particular job shop. What is the sequence in which the jobs should be done, which jobs should be done, which should be left out or postponed for tomorrow. These kinds of decisions are production planning decisions, which are essentially concerned with deployment of resources for the various products. Scheduling of job orders. You might have a number of job orders waiting to be processed. What sequence should they be processed on various machines and equipment? What kind of priority dispatching rule to use, whether you use first in first out, or whether you use SPT or LPT, or you use any other processing rule, that is in fact the part of this, and this also is governed to a very large extent upon the demand for various products. Let us quickly look at the planning process in general, and you will notice that the forecast of demand is an essential input for planning. For instance, what is it that you want? Suppose you are the manager in charge for a certain system, some system to be managed. This system has some objectives, so you know that the system objectives will guide your decisions, and then of course you operate under a set of constraints. The constraints could be the budget, could be the space available with you, and then you also operate with certain level of resources, which could be the men and equipment that you have at your disposal. So, the constraints and the resources you have to keep in mind, the system objectives you have to keep in mind, and of course the demand forecast is a very important input, which will tell you the level of operation that you should actually be indulging in different periods. So, keeping these three major inputs in mind, you come to a plan of action, and the point therefore is that the demand forecast is one of the very essential inputs for planning, and that is why demand forecasting is so important for business. Let us try to look at some of the methods of forecasting. We can club these methods into 5 different groups. The first group is the class of methods which we can call subjective or intuitive methods, and the categories of these methods are opinion polls, interviews, and Delphi. The basic idea is that information is gathered from a set of people, a set of experts on what the demand forecast is likely to be, and this could be done through either an opinion poll or a personal interview or a Delphi procedure. We will talk about these a little later in some detail, but what is the basic advantage of these methods? The basic advantage of subjective or intuitive methods is that you are relying upon the vast knowledge base and the experience of individuals. So, a person who is knowledgeable can tell you what is likely to happen as far as the demand is concerned, and so on. For instance, if you are interested in share price fluctuations, if you probably talk to an influential or a person who is an expert in the area, he would tell you that certain stocks are likely to pick up, certain other stocks are not likely to pick up, and he would have his own reasons for doing this. So, basically that is the major advantage of subjective or intuitive methods. You are banking upon the huge knowledge base of the individuals concerned. Of course, there is a disadvantage too, and the disadvantage is the subjective bias which comes in if you rely upon these particular forecasts. Then we talk about methods based on averaging of past data. So, if you have data available on demand for the past few years, you can use these methods, and the two most commonly used methods in this category are moving averages and exponential smoothing. They are both weighted averaging methods, and we can use these methods to determine what is going to happen to the demand if the previous history is what it is. The third category of models that we have for forecasting are basically regression models on historical data. So, if you have access to information of demand for the last 5 years plotted as a graph, then you can do some trend extrapolation, and based on this trend extrapolation you can project what is going to be the forecast for the next year or the year after that, based on the trend that exists in the historical data. This is a very common method of forecasting, and it is useful because you are using regression to estimate the function which would represent the historical data, and this can be done. Of course, it has limitations. The major limitation of these methods, trend extrapolation methods, is that they essentially assume that whatever was happening in the past will continue to happen in the future as well, which means that you are therefore the trend that was continuing in the past will continue to happen in the future. So, if that assumption is true, these are good models. If this assumption is false, these need not be good models, and the alternative in that case is causal or econometric models. Causal or econometric models are also regression models, but the basic advantage of these models is that you can answer what if questions. What would happen to the demand if the variable such and such drops by so and so? What if the government policy changes to such and such thing? So, the regression models will not be able to answer, these trend extrapolation models will not be able to answer those questions. So, we will examine some of these features through an example subsequently. And then of course, we have time series analysis. We could talk about either time series analysis using decomposition, which is a very commonly used method of forecasting, or we could talk about time series analysis using stochastic models, and in that category we have the set of Box-Jenkins models, which are essentially stochastic models for generating the demand as it goes on. So, you are generating the demand distribution as such and using that for purposes of forecasting. The major advantage of these models is that they are pretty accurate for short term forecasts, but the kind of effort involved in modeling is considerable. So, really speaking, they are not very popularly used. In fact, you will be surprised to know that in a survey carried out on the methods of forecasting used by various industries, the most popular method of forecasting was subjective and intuitive methods of forecasting, and not the other methods. It would be interesting to find out the difference between what we call forecasting and prediction. In schools of management and in IITs and other engineering colleges, they teach you forecasting, they do not teach you prediction, right. Maybe in some schools of astrology they would be teaching you methods of prediction as well, that is a different thing. But the differences I think should be kept in mind. Forecasting is essentially objective, whereas prediction is a subjective kind of a thing. Forecasting is a scientific discipline, whereas prediction is an intuitive discipline. Forecasting is generally free from bias, whereas in prediction the individual bias would come into play. Forecasts are generally reproducible, but predictions are generally non-reproducible. What do you mean by this? What do you mean by the reproducibility of a forecast? What we mean is, for instance, that a prediction is something that probably a soothsayer would give you, a person who is, let us say, imagine a Babaji who is sitting on the top of a mountain, who has a lot of following, and he makes predictions for people, and he is very popular. People go to him to find out their future. So, he is making predictions. Essentially, they follow these all these characters. They are subjective, they are intuitive, there is an individual bias, and it is non-reproducible. Non-reproducible in the sense that if you probably ask the Babaji in the morning about what is going to happen to you or when are you getting married, he will make a forecast. He is in a good mood, he says probably within 6 months. Probably you go to him in the evening when he's probably had a fight with his chelas and is not in such a good mood, and if you ask him to make the prediction again, he'll probably make, no, tumhari kundli mein nahi hai shadi. He might make a prediction to that effect, or might say that no, wait for another 5 years or something like that. So the forecast is not reproducible. However, if you are using a mathematical model for forecasting, if I run the model on a computer in the morning and if I run it again in the evening, I will get the same result. That is what we mean by reproducibility. Of course, error analysis is also possible here. That means you can find out what is the extent of error that the particular method is producing, whereas here error analysis is generally limited in that sense. But in our lives we rely both on forecasting and prediction, and remember that forecasting is a scientific discipline, and that is why it is taught in business schools and in engineering colleges, whereas prediction is something which is intuitive and therefore is generally not taught. Now here we have some commonly observed normal demand patterns. Focus is on the word normal. What do we mean by normal demand patterns? What we mean is that normally what would happen is that demand versus time would exhibit some kind of random fluctuations, but by and large you find that the demand is constant. So this is a typical example of how a constant demand would present itself in real life. On the other hand, if you talk about a store which is gradually increasing its sales over the years, then a linear trend would show that apart from the random fluctuations, the demand would generally tend to rise in this particular fashion, and this could be best modeled as a linear trend. On the other hand, the demand may be cyclic. That means the demand for a product exhibits a peak and then comes down, and there is a valley here, and then it again exhibits a peak, and so on. This is typically true, for instance, of woolen garments. For there is a peak during the months of let us say December or November, December, January maybe, and then there is a dip during the months of May, June, when you do not require. It is only the honeymooners going for sale would go to Connaught Place and tend to buy a woolen coat during this period. That is why this is not zero here. Okay. There would be some buyers for woolen garments even during this particular period, but essentially the demand is cyclic. This would happen for all products for which, can you give me some examples of other products which would exhibit a cyclic demand?
Air conditioners.
Yeah. So air conditioners would be one typical example which could again show a peak in summer and something like this in winter. So now apart from this cyclic demand, what may also happen in practice is that there could be a seasonal pattern but with the growth. For instance, if you look at any particular big store, let us say you look at Shoppers Stop. You have been to Shoppers Stop? So you talk about, let us say, the number of woolen garments which they stock or something like that. You find that in the first year they stock something like this, in the next year their stock increases. So this is because of the general pattern of growth. So although they have a seasonal demand for the product, but by and large it is underlined by a pattern of linear growth. So seasonal pattern with growth. So these are some of the normal patterns of demand which you normally observe for various types of products. Let us now try to look at some abnormal demand patterns. What do we mean by abnormal demand patterns? What happens is that suppose the demand is constant up to a certain level here, and then suddenly there is a rise in demand, and the demand remains constant for some time and then again falls down, and you again remain constant up to a certain level. This is what we call a transient impulse, and this is something abnormal. What we mean by saying that it is abnormal is, what do you think this could be caused by? what could be the reason for a sudden rise in demand for this company, which is operating at this level? Suddenly the demand rises and then it falls again.
In case of some epidemic, the medicines demand.
It could be because of an epidemic, there is a sudden demand for a certain type of drug, you have something like this. Or it could be because of other reasons. It could be because the competitor's factory, there is a strike. If there is a strike in the competitor's factory, then he is supplying the entire demand of both the people for that particular period, and there is something. The point that is to be noted here is, why do we call it abnormal? Because this would be something that is triggered by external causes and would therefore not be modeled in the normal process of modeling, forecasting, demand models. Similarly, there could be a sudden rise like this. Why do you think there could be a sudden rise? Suddenly you are selling so much, and then suddenly you find that there is a rise in the demand. It could be because of the liquidation of your customer. That could be one reason, isn't it? And therefore your demand rises, so you are doing well and you are happy about it. But it could work the other way around. There could be a sudden fall in your demand, and this sudden fall in the demand could be the appearance of a competitor who is much more efficient and much better in terms of price and quality than you are. So your demand suddenly falls at this stage because of the introduction of a new competitor on the scene. All these factors are actually factors which are something abnormal in that sense, right? That means something has happened which is not normally happening, and as a consequence you exhibit these abnormal demand patterns. Why it is necessary to know about these normal and abnormal demand patterns is that normally when you are doing the modeling for demand, you are modeling demand only for normal demand patterns and not for abnormal demand patterns, and these are, as it were, superimposed on the normal demand patterns if you want to actually determine this. So having talked about the common types of demand patterns, let's go to the various methods of forecasting. And as I indicated, probably the simplest method of forecasting is taking an opinion poll. And it can be very easy. For instance, you can take personal interviews. And for instance, what happens is that if there is a manager and he is interested in the sales for the entire region, how would he make the forecast? If the general manager wants a forecast for the whole region, the simplest thing that is done is to aggregate the opinions of sales representatives to obtain sales forecast for a region. So he could say that he will call the first salesman who is responsible for the first region and ask him, how much did you sell this year? He probably say, okay, 80,000 units. He probably might give him a bit of his mind as to why you sold so less. How much will you sell the next year? He'll probably say 100 units, 100,000 units. Okay. So he gets an idea that the 100,000 units is likely to be the likely sales for that particular year, for that particular unit. Something similar could be done for each of the regions, and then ultimately he would, by compiling this information, know the demand for the entire region. So this is how he can obtain the forecast, and the basic advantage is that he has utilized the knowledge base and the experience of the individual salesmen, who are very knowledgeable people because they know their customers and therefore they know how much they can sell, whatever. But the major advantage is the subjective bias, because one particular individual might be very anxious or very keen to satisfy or impress his boss. So he might say, I'll sell 200, and at the end of it he might be able to sell only 100 units, something like this. So the individual bias can always impair the accuracy of the forecasts of this nature. Other methods for taking opinion polls are the questionnaire method. In the questionnaire method, the most important thing is the questionnaire design, which should capture the information that you want to actually obtain. And then there is the choice of respondents. This is equally important, because you must talk to the people who have the information that you seek. So, obtaining these respondents and talking, getting the information from them, and having obtained this, you do an analysis and presentation of results and ultimately obtain a forecast. So, this is how the questionnaire method would operate. Normally, the questionnaire method is pretty slow because the process of designing a questionnaire takes long time, and then obtaining responses from the respondents is also quite slow, and many people may not give the responses. So, you might send out something like 100 questionnaires and you find ultimately that only 10 to 15 responded. So, normally this is the kind of response that you have in using the questionnaire. So, this limitation to some extent is taken care of in opinion polls done through telephonic conversation. The major advantage of a telephonic conversation is that it's fast and you can get an opinion poll almost immediately, isn't it? So, for instance, if you have watched the news on BBC or on CNN or on NDTV, any of these, what do? If there is a major accident somewhere, then they immediately talk to the important people on nearby the site or those who are responsible, and you immediately get instantaneous feedback through this kind of opinion poll on the accident from different people, right? That's the major advantage of telephonic conversation. And the telephonic conversation is good in the sense that it doesn't take too much time from the respondent either. He doesn't have to prepare a report. You can talk to him for 2 minutes, he doesn't mind talking for 2 minutes, and you can get this information very fast. And it's a method where you can disturb a person anywhere, right? I mean, especially with cell phones, you can catch him anywhere, yeah? Even in his even in the toilet, maybe, things of that kind. So, you have therefore this advantage of telephonic conversations. However, what is the major defect of all these opinion polls? The major defect of all these opinion polls is the subjective bias which comes into this place. So, Delphi is a method which has been devised to get rid of the subjective bias, but at the same time to try to get most of the advantages of these methods, which is actually accessing the knowledge base or the experience of these people. So, how does a Delphi operate? A Delphi is a structured method for obtaining responses from experts. It utilizes the vast knowledge base of experts. It eliminates subjective bias and influencing by members through anonymity. That means the people on a Delphi panel don't know who are the other people on the panel. For instance, if I am asked to give my opinion and I know that the person next to me is a Nobel laureate, so in his presence I will probably not be able to speak up my mind and give my frank opinion on what is happening. So, they keep anonymity so that every person gives his honest opinion. It's iterative in character with a statistical summary at the end of each round. Generally 3 rounds are there, and consensus or divergent viewpoints usually emerge at the end of the exercise. That is the purpose. That is either all the, it's like a committee. The only thing is the committee members don't know who are the other members in the committee. And the advantage is that, for instance, if you are interested in finding out how the whatever questions are there with the committee, you tend to pick up those people who are most knowledgeable about that particular aspect, and it could be done from anywhere. So, the nature of the operation is something like this. You have a coordinator for the Delphi panel, and depending upon the problem which he is interested in seeking an answer to, he picks up experts. Now, let us take an example. Suppose, for instance, the question is that I want to forecast when will the petroleum reserves of the world come to an end. Okay. Now, for answering this question, who do you think are the relevant people? Maybe from India you might say, okay, the petroleum secretary would be one person who knows enough about this. Okay. somebody from major oil companies, say maybe somebody from Indian Oil, their director and so on, he could be there, these two people. But then this is something like a global phenomenon, so you would probably like to have somebody from the OPEC countries or the oil based countries who are supplying most of the oil. And then the USA is a major player in all political decisions, so we'd like to have maybe somebody from the United States who is interested, who is responsible for petroleum. So we have a panel of these 5 people. It becomes a Delphi panel. So you'd write to them, or you can contact them, request them to be in the panel. If they agree, you have a panel, and then you ask them the question. And then what happens is, really, we have 5 people. We ask them, when will the petroleum reserves of the world will come to an end? At the end of the whole exercise, what will happen is, somebody might say they will come to an end here, 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 here. 5 people will respond differently to this question. So somebody says the petroleum reserves in the world will come to an end by 2010. Somebody says 2005. Somebody says much earlier. So there are optimists and pessimists and whatever it is. So this kind of information is then mailed to all the participants without telling them who said this and who said that. So they know that this is the range. So you can in fact find out the mean, median and the standard deviation of the responses. And on the basis of this information, the experts can revise their opinions. This is how it operates. So at the end, it might be something like this. Initially, this might be the response. And when the round 2 comes, these people feel, yeah, we are probably too much on the left side, they might want to join them. This fellow might feel that I am too much on the right hand side, he might want to join them. And in the round 3, they might come. And so you have a more or less a consensus. And this would say that this is the approximate date in which the petroleum reserves of the world will come to an end. Alternatively, in the Delphi panel, what may happen is, you have this response to begin with. This person in this round 2 checks his calculations. He says, no, I am perfectly okay. In fact, I should be here. So he comes here and he comes here. And both these blocks take solid stands. So this could be like the Soviet stand in the beginning and the Russian and the American stand. They are very stiff in their stands, and this is what it remains. So this is like moving towards divergent viewpoints. This is also a universal or a useful forecast. Why? Because you can say that there are 2 grades of people in the world. Some people think that petroleum reserves will go on till 2020. Other people think that they will be ending by the year 2005, and that's it. So that again is a forecast in that sense about how it is, what opinions are. Incidentally, I like to tell you the significance of the term Delphi. The word Delphi was actually an oracle in Greece who used to stay on Mount Olympus and used to make predictions, and all his predictions used to come out true. That is why great kings and princes used to line up and wait for an appointment with him to get to find out their future as to what is it the right time to go to war, or should I marry this girl, or whatever it is. So his modus operandi was that whatever problem the king posed to him, he would keep it to himself, and then he had a set of disciples. He would go and tell the disciples, the 5 disciples, look, I posed this problem, tell me what should be the answer. And they would think about it and come up with an answer, and invariably that would be the answer that he would communicate to the king. So essentially, these are the disciples who are basically answering your question in Delphi, and that is the methodology. That's the genesis of the methodology of Delphi. So it's a regular method of finding out exactly what should be done. Let's now talk about the category of methods of moving averages and exponential smoothing. What happens is, suppose this is the demand history for the 1 year that we have with us. So what will happen is that you can calculate a 3-period moving average. A 3-period moving average is something like the demand for January, the demand for February, the demand for March added up, divided by 3 will give you the 3-period moving average, which is computed at the end of March. And this forecast, this will be a forecast for next period. It's a short term forecasting exercise, and when the actual demand comes out, it is 208. So there is an error here of 8, whatever it is. So you take the new moving average. So now the three values are this, this and this, and you take the average 203, which is now the moving average for the next period, and so on. So the moving average will become a forecast for the next period based upon the demand averages for the current 3 periods. You could, for instance, also take a 6-month moving average, which would be available after 6 months. So you have data for the first 6 months, you take the average, you get this value, and this becomes an average for the next period, and so on. So it's a very simple method of obtaining a forecast for various periods, the method of calculation is a k period moving average is the average of the k most recent observations. For instance, in the example that we had done just now, the moving average for May is the demands for March, April and May divided by 3, which were these values, and so you had 206.3. So this was 206.3 that you had here. So calculations are very simple, but it's a very, very simple method of obtaining a forecast. However, the moving averages have certain characteristics, so it's important to know those characteristics. For instance, if the actual demand is rising, shown by the solid line, the moving average will always be lower. That means it will produce a forecast which is lower. Similarly, if the demand is falling, the moving average will always be higher, and it will give you a higher value of the demand than what it is actually. So this can be said by saying that moving averages lag a trend. If there is a trend in the demand, if it is rising, we are below. If it is falling, we are above. So it's always behind. It's like a lagging boy who doesn't keep pace with the class, that sort of thing. So there could be some corrections which could be given for this purpose. If you are having a cyclic demand, the moving averages are out of phase for cyclic demand. What it means is, suppose this is the actual demand, this one. If you calculate the moving average will be little later, like this. So what does it show? It's out of phase. That means this shows a peak, for instance in January, this will show a peak in March, if it's a 3 period moving average. So it will show, it shows कि आग अब लगी है, it will show कि आग लगी है 3 महीने बाद. That is the basic feature that you get for this particular aspect of demand. On the other hand, if this is your demand, the moving average is something like this. What happens in the moving average is, because it's an average, this was showing a peak of so much, but this will actually flatten the peak because of the averaging effect. So it is as if somebody has hammered the peak and you have a lower peak here and a lower peak here as compared to what this is. So these are some of the errors which will come about if you are using a moving average. The other averaging method very popularly used is exponential smoothing. Exponential smoothing is, we have FT is the one period ahead forecast made at time period T, and DT is the actual demand for period T. So this is the forecast and this is the demand, and let's define alpha as a smoothing constant which lies between 0 and 1, but generally chosen values lie between 0.01 and 0.3. Experimentation has shown that alpha should be between 0.01 and 0.3, and we use an equation like this which says FT is equal to Ft minus 1 plus alpha into dt minus Ft minus 1. So this is the demand and this is the forecast of demand made a period before. So this difference is nothing but the error. So forecast made a period before plus alpha times error becomes the new forecast. That is the formula which you use for computation. You can rearrange that equation and write it as Ft plus L is equal to alpha dt plus 1 minus alpha into Ft minus 1. Right? You can always rearrange the equation like this. And then for Ft minus 1, you can again recursively substitute this value of Ft. That is alpha dt plus 1 minus alpha into Ft minus 1 is alpha dt minus 1 by using the same equation, plus 1 minus alpha whole square into ft minus 2, and so on. And if you continue like this, you find that the whole thing is a series which says alpha multiplied by dt, alpha into 1 minus alpha multiplied with dt minus 1, alpha into 1 minus alpha whole square multiplied with dt minus 2, and so on. Now this gives us an interesting result. For instance, if we take the demand data points, this is the most current point at time t, this is the point at time t minus 1, this is the time at t minus 2, and so on. What do you find? That current demand dt gets a value, gets a weightage of alpha. So this is alpha. The next demand dt minus 1 gets a weightage of alpha into 1 minus alpha. The next demand gets a weightage of alpha into 1 minus alpha whole square. And because alpha lies between 0 and 1, you find that the weightages given to the demand points keep on declining exponentially. This is the reason why it is called exponential smoothing, which means that this is a procedure in which, for making a forecast at this point, we are taking the weighted average of all the points in the past, but giving more weightage here, less weightage here, and so on. It's like saying that you are in a joint family, and the person who is the most young person who earns the livelihood for the family, he is asked, he is given the greatest weightage, and then the next one who earns less gets less weightage, and so on. And maybe at this point of time, the old people like the mother and father, who are probably lying on a cot and unattended or most of the time, they are also asked, but very little weightage is being given to them, and that's the kind of thing that you have. Whereas in a moving average, what happens? In a moving average, you consider only the three most recent points. So it's like a American nuclear family, the husband and wife and the child, no other else is there. So you give weightages only to that, and once a point becomes old or the child becomes capable of earning, he is thrown out, and you have the next point which comes in, and you are not giving any weightages there. So the distinction therefore is that in exponential smoothing, you are taking into consideration all the data points, and the forecast is a weighted average of all those points. Whereas in the moving average, you are considering only the 3 or 4 or 6 most recent points, and you are not considering other points. In fact, it can be shown that moving averages and exponential smoothing are equivalent in the sense that there is a relationship between alpha and n, and that relationship between alpha and n is simply alpha is equal to 2 divided by n plus 1. That means if the number of periods in the moving average is large, it is equivalent to a smaller value of alpha. That is the significance of this term. Let's for instance take the demand history for a product that we were just considering, and let's say that this solid line shows the actual demand, which shows over the year what is the demand in January, February, March, April, May, and so on up to December. This is what we have. If you calculate a 3-month moving average, what do you find? This average which is available at this point is shown by this dotted line. This is the 3-month moving average. If you compare this with a 6-month moving average, you find that the moving average, 6-month moving average, is like this. You notice any difference? You notice any significant difference? The difference is that the 3-month moving average is much more responsive to the actual demand. For instance, there is a peak here, so this also shows a peak, and then it comes down because this is a depression here, it comes down and then goes, and then there is a peak, it goes, shows a peak, and then gradually comes down. Whereas the 6-month moving average, it just comes down and then gradually keeps going. So it's more like a big elephant which takes a lot of time to get up, right? And the 3-month moving average is like a deer which responds with agility to the forecast. So if you have a smaller number of periods in the moving average, obviously it would respond faster to the demand. But I mean, the smallest number of periods you can have is 1. But the danger then is that it is not an average, 1 period moving average, then it could show, it gives you false alarms. It could give you false alarms when nothing has happened. An average is a situation where a number of demand points are collectively giving you this answer. So you should judiciously choose between this. And the same kind of effect will be true between alphas, different values of alpha. For instance, if we take alpha is equal to let's say 0.1 and alpha is equal to 0.3, you would very much see the behavior to be very much like for instance this particular value here corresponding to alpha is equal to if you have a smaller value of alpha, a smaller value of alpha is equivalent to, as I said in the it is equivalent to a larger value of n. So it would be a very sluggish kind of response that you would have, and vice versa. So these are some features of methods based upon averaging of past data. Let's now come to the category of methods called regression, common regression functions. So if we have demand points, we can fit any straight line. The most common straight line is a linear relationship. So d dash t is the forecast and dt is the actual demand. We can fit a straight line, d dash t is equal to a plus bt, and what we are actually expected to do is calculate the values of a and b, and this can be done by the method of least squares. We shall go into the detail of estimating these parameters in the next lecture. Similarly, a common demand variant is a cyclic demand. So in the cyclic demand, what do we have? We have d dash t, which is the forecast, would be equal to a plus u cos 2 pi by n into t plus v sin 2 pi by n into t, and this becomes the forecasting model. N is the number of periods, number of the periodicity of the data. If this whole cycle repeats after 12 months, then periodicity is n, 12. And so this was the given data. You fit this function, and here you have to estimate the three parameters a, u and v. These are the three parameters. So once you estimate these parameters, you know the function completely and you can use it for forecasting the demand. Similarly, you might have a function with growth, cyclic function with growth. So the equation for this line would be d dash t is equal to a plus bt plus u cos 2 pi by n into t plus v sin 2 pi by n into t. The parameters now are 4, a, b, u, v, and these have to be estimated. Once they are estimated, you can. The point that we are trying to say is that there can be different mathematical functions. You have to identify the appropriate equation and then use the data to estimate those parameters. Or you might have a quadratic function, which means which goes like this or like this. So the equation is d dash t is equal to a plus bt plus ct square, and you have to estimate a, b and c. Obviously, if c is positive, you go this way. If c is negative, you go this way. And again, the parameters have to be estimated by determining the sum of squares of the errors. For instance, if we take the demand example that we were considering all along, we had, this is the pattern of the actual demand. What would happen is, if we decide to fit a straight line to this model, the straight line that is fitted is ft is equal to 193 plus 3t, and this equation when plotted is shown here. Now if I want to make a forecast for next January, suppose I have this entire year from January to December and I want to make a forecast for the 13th period, that is the January, what happens is I can utilize the notion of the standard error of estimate to get intervals in which the demand may lie. How will I do that? Because if I put, for instance, in this t is equal to 13, I have 193 plus 3 into 13, which is 39, and the value is 232. So the expected demand for next January is 232. But what I can do is I can find out the standard error of estimate, which is nothing but the summation from 1 to n of dt minus ft. This is the error. So sum of the squares of the errors divided by n minus f, where n is the number of data points that you have and f is the number of degrees of freedom lost. The number of degrees of freedom lost in this case is equal to 2 because you have estimated only two parameters. This is a straight line equation, a plus bt. You have estimated a and b. So the number of degrees of freedom lost is 2. As a consequence, the standard error of estimate works out to 7.32 or approximately 7. So what you can do is, if you want the 95% confidence limits for the forecast for next January, 232 was the value that we obtained, plus minus 2 sigma for 95% confidence. So you would get 232 plus minus 14. This gives us some very useful information. For instance, this shows that the demand for next January may lie between 218 to 246 with 95% confidence. So we can make probability statements like this and make more exact forecasts by using the concept of the standard error of estimate. Then we can talk about, after we talked about trend extrapolation models, we talk about causal models. Here demand is related to causal models. What are causal variables? They like the gross national product, the per capita income, the consumer price index. These are actually published figures which would be available to you before. So these are generally taken as causal variables. And let's see, for instance, how we make a causal model for the demand for tires. You see, what we could do is, if we were interested in the demand for tires, we could just plot historically and do a regression analysis of the kind that we just indicated. But that doesn't tell us what would happen to the demand for tires if there were certain changes in government policy and so on. So we say that the demand for tires is a function of primarily the production of new vehicles and the replacement of existing autos and the government policy on automobiles, etc. It is dependent on this. Each new automobile produced requires 5 tires. And then most of the tires are there are replacements of existing autos. So it goes in that, and then of course the government policy on automobiles. So if we make a model saying like this, that the demand for car tires is a function of, is alpha times PT. PT is the production of cars in time period T. This you know. What is the government capacity for car production? And let us say beta PT minus 5 is, this is the production of cars 5 years ago. So you can say roughly that cars which were produced 5 years ago, they would come for replacements. Of course, cars which were produced 1 year or 2 years, 3 years, they would all come for replacement. You can include that in the model, but it would make it a very complicated model. So just as a simplification to illustrate the notion, we can say that the demand for car tires is alpha PT plus beta PT minus 1 plus gamma. This could be a simplified causal model. These are the parameters which have to be estimated by regression from the data. And ultimately, what's going to happen? This is useful because if the government decides to cut the production of automobiles for reasons of pollution or other things, you know PT for that particular year, you can then directly find out the demand for car tires. These are the kinds of what if questions that can be answered by causal models. Of course, for a causal model to be useful, the causal variables should be leading. Leading means that their values should be obtained before the time that it occurs. Otherwise, they would not be available. And they should be highly correlated with the variable of interest. So the correlation between dt and bt and the correlation between dt and pt minus 5 should be fairly high. That is essentially the notion of causal models. Finally, we come to the discussion of time series analysis. Time series can be decomposed into trend, seasonality, cycle and randomness. And once we isolate these components, in time series analysis what is done is that the forecast is generated from these components. You find out the various components of the time series and put them together and find out what these components are at the new period of time and get the new forecast. So that's the essential philosophy. In stochastic modeling of time series, which is the famous class of models due to Box and Jenkins, there are various processes such as autoregressive process of order P, moving average process of order Q, and combining these we get autoregressive moving average, so ARMA process of order P and Q, or it could be integrated, autoregressive integrated moving average order of P, D and Q. So these are the most commonly used processes which are used for constructing models of the Box and Jenkins variety, and the basic idea is that these are stochastic processes in themselves, and the model generated is a stochastic model, and these models are accurate for short term forecasting but highly cumbersome to develop. So I think this gives you some idea of the various class of models that we have. Finally, the more important thing for any forecasting system, whether it be opinion polls or forecasting or regression or time series analysis or anything, is that the forecasting system has to be validated. How is it validated? You have past data, you are using this for forecast generation, so you are getting a forecast which you send here, and then actual data on the new forecast becomes available. So you have forecast control here, which compares the errors, and these errors are then subjected to managerial judgment and experience, which tell you whether the forecasting model that you are using is fine, and then you can use a modified forecast. So this is to be a continuous forecast control system which tells you exactly, it's basically on monitoring of the errors. If the errors are becoming very large in monitoring, it shows that there is probably something wrong with your forecasting system. In order to keep track of this, a control chart is used. It's generally called a moving range chart to control forecasts. And what happens here is the moving range is defined as, this is nothing but forecast minus demand. So this is the error in time period t. This is the error in time period t minus 1. So error in time period t minus error in time period t minus 1, and the mod of that is what we take. It's called the moving range. So if you have n data points, the moving range, the average moving range will be summation of mr divided by n minus 1. Why n minus 1? Because for n points there will be only n minus 1 moving ranges. Okay, this way. So you can then calculate an upper control limit which is plus 2.66 mr bar. This is valid for any forecasting system. And you have a lower control limit which is minus 2.66 mr bar. Having computed these limits, it becomes very easy to plot a control chart. So what we do is, we have the upper control limit and the lower control limit, which is plotted plus minus 2.66 mr bar, and the variable to be plotted is the error ft minus dt. So error at this point is so much, next time is this, next time. If the error remains within this control limit, it shows that the forecasting method that you are using is consistent and it is okay. If the error goes outside, it's a point out of control, then you have reason to suspect that there is either an assignable cause or your model has actually gone awry. So let us summarize what we have tried to do in this particular lecture. We have looked at the forecasting problem in totality. We have looked at the importance of forecasting in planning decisions. For all kinds of decisions, long term, medium term and short term, we have forecasting is an essential input. Then we looked at the various methods of forecasting, the subjective methods like opinion polls and Delphi, the moving averages and exponential smoothing procedures which are based on averaging of past data, trend extrapolation by regression, causal models, and the time series decomposition. And finally, we looked at this process of forecast control, which was essential to tell us whether the forecasting system that we were adopting is appropriate or not. We shall actually look up or dwell on the details of many of these methods in our next lecture.